Alright, welcome back. Let's do question 13. In the diagram below, a house is in the shape of a prism with a triangular shape roof with one side CN equal to 10 meters. A vertical tree is grown at a point T in the garden. Angle NCT is 65 degrees and then angle CNT is 69 degrees. The angle of elevation, the top of the tree, is 43.5 degrees. So it means this angle here should be 43.5 degrees. Is it possible for the tree to hit the house if it falls? Show all working. Let's discuss this. So it means now we need to find the height of the tree, isn't it? We have to find the height of the tree. Let's call it h. Right? How can we find the height of the tree? We can find the height of the tree if we have maybe the side CT, if we have the side CT, because we have the angle ACT. So using the angle ACT and then the side CT, we can find the height of the tree, right? Okay, and then the other thing, we need to find the distance now. Let's call this point P. Let's call this point P. So we need to find the distance PT, like that. Okay, now how can we find the length of the side CT? Right, if we check, we have the angle and we may find the side CT, and then we have the side here 10 meters CN. We can use this side with the angle T there. So we need to find this angle T or angle NTC, right? How do we find angle NTC? We can use angles in a what? In a triangle. Right, remember when given two angles and one side, we can use the sine rule. Or when given two sides and a non-included angle, we can also use the sine rule. We want to find side CT. We're going to be having angle CTN, isn't it? We're going to be having angle CTN. So we're having two angles and a non-included side. So we can use what? We can use the sine rule. Let's find angle CTN is equal to 180 degrees minus 69 degrees minus 65 degrees, which is equal to 46 degrees. And then the reason you write sum of angles in triangle. Right, so it means this angle here is 46 degrees. This angle is 46 degrees. Right, now we have angle CTN, and then we have angle CNT, and then we have side CN. We can find CT here. Okay, so use the sine rule. 10 over sine 46 degrees is equal to our CT that we're looking for over sine 69 degrees. Right, therefore CT is equal to 10 times sine 69 over sine 46 after multiplying both sides by sine 69. And then we get that this is equal to 12,97829518, like that. Now let's look at triangle ATC, this one which is like vertical almost, right, formed by the tree and what? And the line CT there. We say the angle of elevation here, this angle is 43.5 degrees. So we can find what? We can find the height of the tree. We just found that CT is 12,978. It goes on like that. Okay, so we can use our side CT, which is adjacent, and then find the side H, which is opposite. So which ratio are we going to use? The tangent of the angle. So we can say tan 43.5 degrees is equal to the opposite side over the adjacent side, which is h over 12,97829518, like that, right? And then we multiply both sides by 12,97829518 to get h. And then what do we get? H is equal to 12,97829518 tan 43.5 degrees. Okay, then you can put this in the calculator. H is equal to 12,3 1594226, which is roughly the height of the tree being 12.3 meters. Now we need to find this distance here from the tree up to C and there. If the height of the tree is bigger than this distance, then means the tree when it falls is going to hit the building. But if it is shorter, it means it won't hit the building. So we need to find this distance. Say, let's call this point P. So we want to find PT. What you can do here, we can use triangle CPT, right? This is like the opposite side. PT is like the opposite side, and then 12,978295 is like the hypotenuse, and then our reference angle is 65. Okay, so now we can say sine 65 degrees is equal to the opposite side, which is PT that we're looking for, over the hypotenuse, which is 12,97829518, and then we multiply both sides by 12,97829518, then get that PT is equal to 12,97829518 sine 65, and then put this in the calculator. We get that PT is equal to 11,76232998, like that. So roughly PT is equal to 11.8 meters. Okay, right, the tree is 12.3 meters. This distance PT is 11.8 meters. Therefore the tree will hit the house.